Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Today we're talking about an incident that occurred in East US. It was an incident that was predominantly due to capacity, which started on the 18th of June. But towards the tail end of the incident, we had another issue, an Azure Allocator issue, which kind of was in the same window. So there were two separate incidents. Customers felt it as one kind of impact window, and that's what we're here to talk about.
I would say we've got a couple of leaders here to talk to you today who will introduce. We also have our question and answers running alongside. So you'll see there's a Q&A button in the top right-hand corner of Teams Live Events. You can ask any questions you have about the incident, about the post-incident review, or about anything we cover here today. So with that, let's introduce the engineering leaders that we'll be talking to.
Super. First, joining us is Paul Nash, our Corporate Vice President of Azure Core Infrastructure. He'll be talking to us about the capacity issue. Welcome, Paul.
We also have David Dion, our Principal Software Engineering Manager from the Core Infrastructure team, specifically looking at the Allocator. And we're going to talk a lot about what the Allocator is and what kind of issues we had with it.
Super. Paul, can I start with you? But before we get into the incident itself, I think about Azure that we have 300 data centers, we have 60+ regions. The scale is absolutely enormous. And of course, backing all of this is capacity and how we manage capacity. How do you think about and how do you manage capacity at the scale that we operate at?
Yeah, absolutely. So thanks for having me here today, first of all. And I want to really start by underscoring to our customers that we understand exactly how much you rely on and trust Azure to always have the resources and capacity that you require to run your businesses. And so we take these incidents very seriously. And part of that is being here today to talk about what happened so that we can capture those learnings, assure you that we are learning and improving, and hopefully not have a repeat of any of these situations. So, you mentioned 300 data centers, 60 regions, et cetera, and I would say, and growing all the time in a literal sense, at every level of the spectrum, whether that is a brand new region, brand new data center, brand new building in an availability zone, new data hall in a facility, or indeed servers, which we take delivery of on a continuous basis. So our plan, put bluntly, is to guarantee the idea that cloud is infinite by making sure that we are always delivering the capacity that customers need before they need it. We use a sophisticated set of planning and modeling and forecasting tools and a lot of additional input from our field sales and customer engagement teams and customers themselves who plan with us to assess what's going to be needed, and in every ideal scenario to make sure that we have that to a very high statistical guarantee, so that when customers show up and want to pay for what they use and they need to use a little bit more, that is available. As part of that, we also, like I mentioned, will engage specifically with very large users or users that have seasonal or less predictable demand. So it's not just a data-driven model, but we also gain intelligence and insight by working closely with customers when they have very large or hard to predict needs, so that we can properly account for that and adjust our plans and supply chain and so on.
That makes a lot of sense. And so if we zoom into this issue in East US, it was about 35 days prior. I think in the PIR we mentioned the 13th of May. We saw our signals were tweaking, our Spidey sense was going off, and we needed to intervene. Yeah. What interventions did happen 35 days prior to this starting?
Yeah, so as you can imagine, I've just told you our goal, and our goal is perfection. The reality is, with all of those different locations and with the different types of products that we are offering, requires a broad variety of different servers, different infrastructure, different hardware to meet those needs. And there are cases always where that fact that we don't know who's coming next exactly and how much they're going to ask for means that we will start to see what we think of as demand signal, that may move faster than what our current plan is to deliver supply to a location. In some cases, the adjustment to that is as simple as accelerating the next set of servers. In other cases, it is accelerating the next data hall. In some cases, we will see that there is a difference between the rate that demand is arriving currently and the rate that we anticipate supply will arrive. And so in those cases, like the one you described, several weeks before the outage, we noticed that that trend was starting to take place. And when that happens, we have a set of mechanisms that we can put in place to understand the demand better, to remove some uncertainty, to make sure that we do not run out of capacity. And one simple mechanism for that is, as you can imagine, Microsoft is not only a cloud infrastructure operator, but we provide many cloud services, which in turn run on that infrastructure. And then we have our own internal workloads that also use that infrastructure. So one of the first steps we will take when we start to see an imbalance forming between supply and demand is we will pause the allocation of any new Microsoft internal workloads to that region or to that zone, or maybe even just to a product type, to control the demand that is completely within our control and make sure that we are prioritizing the demand or the supply that we have for customers.
That's great to hear. So we had that kind of foresight. Our data told us there was something going on, and we started to pull these levers. We started to shape that demand. Well, if we fast forward to the 18th of June, it seems like those efforts, all those levers that we pulled, well, they weren't quite enough to avert, failures. So come the 18th of June, customers start experiencing allocation failures. Now what? How do we respond? What more, more powerful levers do we have to pull when that is now, not some far off problem? It's actually already causing customer pain, Paul.
Yeah, unfortunately, in this case, on the 18th, we saw that there was a significant increase in demand above and beyond what we would have expected on any normal day, looking at our data, looking at what we knew about customer growth. And that did lead to our alerting starting to detect that the process of requesting a VM, something that we call an allocation, started receiving error messages. So customers were receiving errors or notices that they were unable to obtain some of the resource types that they would expect to obtain in one particular availability zone out of the 3 in this region. And so at that point, our alerting mechanism kicks in. We begin an incident bridge. We call in our on-call or dedicated responsible individuals to begin investigating that situation. And we have a playbook of a whole set of different things that we can do in response. Just to give some examples, I mentioned that we had paused the entry of new Microsoft internal workloads to the region several weeks before. We also have the ability to take any existing Microsoft internal workloads that are not business critical or production facing offline in that location. And we will implement that step. We will also take certain non-time critical workloads that may support production, such as batch processing, et cetera, either offline or start investigating moving those to another location that's not affected. And then even for some production serving workloads, we have the ability over a course of time to move traffic to another location, freeing capacity for customers that may not be able to move. And so we started through this playbook. There's a number of other investigative steps we take too, but from that perspective, that's sort of the first set of things. And each of these has a sort of different time horizon to how quickly they can be executed to free capacity in the region. So we start almost all of those in parallel so that over time, we will see increasing amounts of supply become available.
I have a follow-up question. Is it an easy task to be able to identify all the internal workloads and evacuate them quickly? Like it sounds pretty mammoth when I think about it. There's hundreds, thousands, maybe millions of workloads running in
Sure.
our data center in East US. How nimble are we when it comes to a job like that?
Well, it really depends on the workload. I think many customers will understand it's sort of similar to their situation. There are certain workloads that have very little state and have been designed with a very flexible sort of cloud-aware pattern and really don't necessarily have a lot of opinion about where they run. And so we will deploy those workloads across regions to balance our growth and capacity. And those are relatively easy to move. There are some other workloads that are either very latency sensitive or position sensitive, or perhaps have a significant amount of data or other complexities that do take days or even weeks to migrate. I'm sure many customers will understand if they have maybe something like a mission critical enterprise resource planning workload, you can't just flick that across the country on a moment's notice because there's a lot of data. And finally, then, of course, there are other complications for things like data jurisdiction, right? We can't move customer data across certain boundaries, depending on the type of data. And so we have a process whereby we can assess that. We have a set of workloads that we will turn to that we know who is in the region, and we can sort of work through that. But that variation is one reason why the timescales are quite different.
Got it. Thank you for helping us to understand that. I'm interested in the different ways this might have impacted customers during that weekend that we experienced failures. Well, what would that have felt like between kind of IaaS, infrastructure as a service, just raw virtual machines, versus some of our PaaS services? If I think about web apps or SQL or Redis cache, like how would that vary? Do they get the same failures, or do we manage capacity differently between PaaS and IaaS?
Yeah, so both Microsoft's workloads, whether it's IaaS, PaaS, or even software as a service, they will have quite a few differences in terms of how they allocate this. So, and most PaaS or SaaS workloads, including those provided by third parties that might be running on Azure, will have differences in their approach to whether or not they buffer capacity, how they think about growth. I think the important thing to think about is that this was a capacity availability incident, or what I sometimes will refer to as obtainability. The primary way you would experience this is if your workload is trying to grow or migrate or redeploy or change in some way during the period where this incident was affected. Running workloads did not experience any issue if they were statically running with a current set of resources. Additionally, it's a little bit of a surge thing. So we will see there's always customers that are trying to create VMs. There are always customers that are releasing VMs or destroying them. And so with that, capacity levels will fluctuate, though, below the levels of availability or buffer that we would like to have. So that causes the issue to be intermittent, where you might get an error one moment, but then if your workload is set up to retry, you may get your resource. And then as far as you're concerned, it was a blip on the radar. Some workloads are configured to do that. Some workloads will speculatively request capacity that they don't need, but they're simply asking whether or not it's available, and that would not be considered an error to them. Additionally, for performance reasons and scale reasons, some things like PaaS and SaaS workloads may have a set of capacity resources already allocated that are ready to go when they see an increase in demand for their services, and they wouldn't have seen an error in this case. So it really depends quite a bit.
So, and Paul, is that different when you talk about, okay, PaaS services would have spun up some capacity beforehand, even if it was not utilized? Is that different to the capacity pools and some of the things we spoke about in the PIR? Because we said we had pools of capacity and there was design limitations, which meant that we were drawing from the wrong pools, depleting the public pool versus the kind of allocated pools.
Yeah, absolutely. So, we talked a little bit in the PIR, I think for the first time, about the concept of different pools of capacity. And I think the best way to think about this is maybe as a construction site, where we are sometimes in planning for expected large growth. For example, let's think about something like Black Friday, Cyber Monday in the US, which is a large seasonal retail period where many of our customers will spin up much more capacity than they might during the rest of the year. For obvious logistics reasons, we don't take delivery nor spin up all of that capacity the very second before we anticipate that those customers are going to request it. So we have many servers, many racks, sometimes entire data halls that are being prepared to introduce into the fleet. And we will stage that capacity, much as you might stage the lumber for a building that you're about to build, even though you don't need all of it yet. You're only building the first floor or a part of the building. You might have all the lumber delivered at once. And so we have some pools like that we are holding in order to meet anticipated demand that we are aware of, given the planning system that I described earlier. And when that happens, those pools are not yet available for just any customer that would show up in a zone or region and make an allocation request. They're removed from what we call the shared pool of resources.
Got it. So, Paul, would you help us to understand then, when we mentioned these design limitations, it sounded like during this incident, even when there was available capacity in that public pool, things weren't kind of coming from the right place. Could you talk a little bit about what was wrong, that was a problem in the way that we designed the system?
Yeah, so maybe it would help also for me to sort of mention some things that didn't happen that we go through in our investigative procedure. As I join the technical bridge, we ask a series of questions. Is this due to a code deployment that maybe has affected how the system works? Is this due to a config deployment that might have affected this? Is there something going on elsewhere in the world that might have impacted it? Unfortunately, also, there are always bad actors that are looking to obtain cloud capacity without paying for it. So one of the things that we also look for is whether we see any suspicious accounts or fraud, or more frequently, whether we see any legitimate accounts that perhaps have been compromised where a threat actor is using capacity in that account on somebody else's dime. So we look through all of these things and we rule those out. And after doing that investigation, what we determined is that a small set of customers had made a significant number of additional allocation requests for capacity that we would have anticipated would go to the pools that I mentioned were in staging earlier. Unfortunately, instead, they went to the shared pool, and that's a sort of a combination of a sort of policy issue and a communication issue that we discovered and that we are currently rectifying. But essentially, unanticipated demand went to the shared pool, which quickly resulted in the shared pool being exhausted in our physical availability zone 2. And customers should check to understand how that logically maps to the availability zone numbering they would see. But that capacity quickly exhausted what was currently online in AZO2, leading to the beginning of the incident and allocation failures.
So that makes sense. And so you're pulling these levers from the 18th up to the 20th, and
Yeah.
we're almost mitigated, and everything's we're climbing out of the woods. And then suddenly, David Dion, if I can turn my attention to you, the allocator capacity starts at maybe the worst possible time it is, but just as we're kind of getting out of the capacity woods, allocator kicks off. David Dion, please, could you tell us what happened?
And what an allocator is and what went wrong with it.
Sure. Yeah, it's probably good for me to start by talking about the allocator a little bit because customers don't typically interact directly with the allocator. So customers might be using virtual machines or virtual machine scale sets or Kubernetes or Databricks or any of these other services ultimately are going to be running in virtual machines. And something has to decide which physical machine in an Azure data center these virtual machines are running on. And that's what the allocator services do. So the allocator services have a very complex problem to solve. Azure has hundreds and hundreds of different virtual machine sizes, and we also have many constraints that customers can impose upon their services. So for instance, spreading those virtual machines across fault domains, or using premium storage, or using dedicated hosts, or using spot VMs. So these are all requirements placed on the allocator to make intelligent and correct decisions on how to run these customer services. So what I'd like to do now, just to help illustrate a little bit, is pull up a diagram. And this is a diagram that I pulled from a research paper that we wrote with Microsoft Research a few years ago about the allocation services. So everything you see here exists in each availability zone in Azure. So this is a picture of the allocation services and dependencies and clients in each availability zone. So what you see under the box called Protean are the allocator services. The client services, those would be, for instance, the compute resource provider. Those are where the requests for allocations are coming. And then the other important box you see here is the pub sub service, and that will be important as we describe what happened in this particular outage. So the pub sub service is it's built on Kafka, and it is a shared service used by a lot of different services, not just the allocator services, and it provides publish subscribe functionality. And for all of the complex allocation logic, which is running in the allocation agents that you see pictured here, all of the data that complex logic requires comes into the allocation agents through the pub sub service. So for example, if you think about what Paul just described in terms of new machines coming online in Azure, the allocation agents will learn about those through the pub sub service. If one of those machines changes its health, it goes into a failed state. So the allocation agents learn about that through the pub sub service. Any existing customer virtual machines running on these machines, that also comes into the pub sub service. So we had that very strong dependency on the pub sub service. And in this particular outage, the pub sub service had a change imposed upon it by one of the other users of it in the Azure platform, and they had performed a security change, which imposed a lot of additional load on the pub/sub service. And this actually happened several hours, actually even a day leading up to the outage. Now, this was all at about the same time that we were experiencing capacity issues in the East US region, but from a root cause perspective, they were completely unrelated events, okay? So this security improvement was being applied as part of normal operations. It had been applied in many other regions already. It just happens that in the East US region, it caused this high spike in demand on the pub/sub service. So leading up to the problems, we actually noticed that we were seeing performance issues with the pub/sub service. And we reached out to the team that operates that service, and they said, yes, we've seen this also, and we're working on getting it mitigated. And so we were feeling confident that it wasn't going to lead to any worse problems. Unfortunately, a few hours later, we had just an unrelated update that was applied to the allocation agents. And when we apply an update to the allocation agents, they get restarted one at a time. Now, in a large availability zone in East US, we will have several of these allocation agents, 10 or more. And the first one was restarted to take the update. And unfortunately, what we learned at that time was that although the existing connections to the pub/sub service were still running okay with some latency, the establishment of new connections was what was really failing. So when that first allocation agent restarted, and then it tried to connect to the pub/sub service to rebuild all of its state so that it could perform allocations, those connections all failed. And that caused the entire upgrade to stop, right? So at this point, we had one agent down and all the others running, no customer impact yet. Now, unfortunately, the deployment system detected that this unhealthy situation, and it interpreted this as an emergency. And it said, oh, goodness, we have to quickly roll everything back. And unfortunately, as part of that rollback, it restarted all of the other allocation agents. And this is where things started to go really bad, because now all of the allocation agents were all starting at the same time and trying to connect to the pub/sub service, and they could not connect. And at this point, all of our monitors started yelling at us, and we knew that we were in bad shape. Any customer operation that would require an allocation, this would be deployment of a new virtual machine or a change to an existing virtual machine, all these were going to start failing in this one availability zone in the East US region. So at that point, we turned all of our attention to working with the pub/sub team to get their service back up and running. And after several hours, we successfully helped them mitigate the problems they were having. But then the allocation agents still did not restart. And this is where we really had to start to scramble to figure out what was going on. And we realized that the demand through retries, both initiated by customers and within the platforms, had grown to such a large amount, also partly contributed by the other capacity issues that were occurring in the region. So we had so many retries happening that there was so much load on the allocation agents that they were not able to process all the incoming data from the pub/sub service. So at that point, we worked with partner teams to basically shut down any new virtual machines going into the availability zone. Now, in reality, they were all failing anyway, so this didn't make any demonstrable change to customers, but this just made any attempts even to try to fail, and it automatically diverted all of those customer requests to the other two availability zones in the region. So at this point, that started to decrease the load on the service, and after that step, we were starting to get allocation agents back up and running, and then we were able to bring the entire zone back online again. Now, to some extent, while we had this issue with the pub/sub service and we were down, there were some deletes by customers that were still occurring, and some capacity was being freed up. And so when we brought that zone back online, we did have available capacity in that zone, and that helped to mitigate the overall capacity issues in the region.
David, that's a great summary, and I was following along in the diagram there. So we know exactly what went wrong. I want to save some time to get back to Paul to talk about some of our learnings and repairs from the capacity perspective. But while I've got you, what are our learnings and repairs from the allocator perspective? I know we mentioned in the post-incident review that we need to be able to shed that load more rapidly, but I also understand you're working with some of the clients who use the allocator. Well, what are we going to do differently, or how are we going to improve next time?
Yeah, there's several things we'd like to do here. So although the pub/sub service is a key dependency for us, we also need to recognize that there are things we can do even while it's in a degraded state. And so we, for instance, want to detect and react better when we determine that there are performance issues with the pub/sub service. So we should not have allowed all of our other service instances to restart, right, while the pub/sub service was having connectivity problems, right? That's one thing. We could have been running in a degraded state, but still performing perfectly valid service for most of our customers, even while the pub/sub service was having performance issues. So that's one key learning. Also, like you mentioned, we need to be able to surgically and quickly shed load faster than we did in this particular case. If we had been able to shed load within a few minutes, we could have brought the Allocator services back online hours faster than we did. And so that's a key learning. And then also, we want to become more advanced with the graceful degradation we can perform if there's a partial problem in the AZ pub/sub service. So for instance, if we're able to get data about some machines but not others, we need to be able to make sure that we can still perform allocations on as much of our capacity as possible so that customers don't see a full zone problem. Maybe they see a partial zone problem, or as Paul was discussing earlier, maybe we have an issue with some pools of capacity, but most pools of capacity are still online.
Super. And Paul, if I can talk about some of the repair items from the East US issue because of capacity, reading the repair items, I was blown away that we have a data center that is about to be brought online. We have another data center that's coming to the region. We're still continuing to grow and add new capacity to the region. It seems like quite a phenomenal rate.
Yeah, absolutely. So I think that's the key, is that this was a temporary incident. And unfortunately, there was an imbalance and then a complicating factor as well. Depending on your point of view, either fortunately or unfortunately, we were very close to receiving the next tranche of data center space and deploying servers in that space that would have taken us back to the point where we were not managing carefully on growth. So we have since received multiple facilities, and we have a construction plan that will deliver more over time. So I think it's important for customers to understand that this is not sort of the limit of the region, or we haven't decided in the last week to go build a new data center from scratch. This is part of us managing, the incredible but sometimes unpredictable growth of cloud demand writ large across our customer base. And as I mentioned at the beginning, our goal is to get that perfect. Unfortunately, we missed a little bit in this case.
Makes sense. Thank you for explaining. I'm glad you checked that the concrete was dry before we put more servers in there. And then some of the other learnings and repairs that we mentioned in the post-incident review. Yeah. Just wanted to touch on them briefly. You talked about rebalancing those pools better and some better error messages for customers, maybe some changes to our policy restrictions. Is there anything else from a process perspective that we're going to do differently, Paul?
Yeah, well, so on the policy restrictions, and I might not have mentioned this up front, but one of the things that we will do when we start to see weeks or months ahead that the demand is picking up ahead of supply, for example, is we have a number of decision points in how we operate our business. For an example, how much quota will our automated quota request processing system authorize by default? And we can tune those levers in order to prioritize and reserve capacity for the customers that are in the region, that are growing, et cetera. We have a number of different mechanisms we can use there. I think one of the key learnings for us there, of course, we're always very careful about when we deploy those mechanisms, because those equate to additional friction for certain sets of customers in certain cases, and sort of erode a little bit at the ideal state, which is that cloud is infinite, as I mentioned. So I think one of the things that we've talked about internally and are evaluating is, should we have applied stricter policies to help shape that growth and guide customers in how they're choosing to use the region earlier when we started to detect that imbalance. And like I said, it's always a bit of a trade-off, but something that we will always look at and try to learn from, so that we don't run out for customers' needs.
Great. Thank you for explaining that to us, Paul. And then I always save my last question here for my co-host, Sammy. Sammy runs our Azure communications team. So, Sammy, it sounds like a couple of incidents overlapping here. How did we do in terms of keeping customers impacted customers? How did we keep them informed?
It was a mixed bag. When we're just thinking about the capacity issue for the first part, we communicated to customers saying, hey, capacity is tight here, you should try another SKU, you should try another region, depending on what they're trying. That was fine, and that was pretty much being managed by Brain. There are some limitations there. I think it's difficult for customers to spin up a virtual machine and then in Azure Service Health get a notification. We want to make sure that if we can, we want to bring that error message into the product. So as customers fail, they can get helpful error messages. As Paul mentioned, we want to partner there. So that was kind of running its course for those 2 days. We were giving customers guidance. The allocator issue threw a spanner in the works. And the reason is we didn't quickly correlate. David Dion and team were quickly understood that it was an allocator issue and they're working with a pub sub service. But for the communications team, we weren't fully informed. We didn't connect all those dots yet. And so different services responded differently. Brain did fire, and Brain is our automatic communication mechanism that notifies impacted customers what's going on. But Brain did fire for some services, so for like Data Factory or Azure Synapse app services, they would have received communication through Brain. Customers using Azure Databricks, that was more of a manual thing, and so there was issues there. So it was an inconsistent experience. Our Brain technology as well created different tracking IDs. So if customers were using a combination of Databricks and Azure Data Factory and an IaaS virtual machine and Synapse, they would have received multiple tickets, which is difficult to correlate. And as I said, some of them we kind of understood, okay, this is due to an allocator issue, and some of the other ones thought it was down to a capacity issue. So it was very muddled and very confusing, I think, for a lot of customers for the most part. We tried to clear this up towards the end with the PIR and say, hey, there was an allocator issue, there was a capacity issue, but teasing them apart and landing that was quite tricky. So I'm pleased we got a chance here. One of the other things that tripped the Brain system on and off is that while, as we mentioned kind of throughout this incident, capacity did free up and then it got consumed, and then it freed up and then it got consumed. And as a result, our Brain system thought, oh, it's mitigated. No, it started again. It's mitigated. And so customers would have received kind of flappy alerts saying, hey, we're good. Nope, we're bad again, and so on. So I think there's a lot of automation that was a problem. And then we had a human problem of being able to step back and kind of understand that there are two separate incidences going on and trying to tease those apart. So we have a lot of work to do in the comm space.
Got it. Good. Just as Paul has some learnings from a capacity perspective, David has some learnings from an allocator perspective, and Sammy has some learnings from a comms perspective. So lots of repairs and learnings to go around. I'm mindful of time. We're just a few minutes over here. Special thank you to our speakers for joining us. Thank you, Paul. Thank you, David. I really appreciate you coming on and explaining to customers what happened and how we're improving here. Thank you to our experts answering Q&A down the side. I hope customers took advantage of that opportunity to get any questions answered. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.